This is section 5.3, solving quadratic equations by factoring. Our objective today is I can factor polynomials and I can write a quadratic equation in standard form given its roots. And here we can see that they gave us what standard form looks like. It's just where we have the squared term, the regular x term, and then the term that doesn't have any variable with it. The factored form is just where we've factored what we have into two pieces. We can use the FOIL method to write a quadratic equation that is in factored form in standard form. Example 1 wants us to write a quadratic equation in standard form with -2 and 6 as its roots. So the first thing we're going to do here is just write what this is going to look like. So we're going to have x minus p times x minus q equals 0. And p and q are just those numbers that we're going to be plugging in. So let's go ahead and do that. So we know that one of the roots is -2. So for p, we'll plug in -2. And then we know that the other root is going to be that 6. So we'll plug that in for the q. So now we can just go ahead and simplify. So since we have two negatives with the 2, we'll have x plus 2, and then we'll just have x minus 6. And then we want to go ahead and use that FOIL method to turn this into the form that it wants it in, which is the standard form. So if I have x times x, I'll end up with x squared. X times -6 gives me -6x. 2 times x gives me 2x, and 2 times -6 gives me -12. And then I can go ahead and simplify that. I can simplify those x terms. So I have x squared minus 4x minus 12 equals 0. And that's going to be my final answer written in standard form. In Algebra 1, you learned various techniques for factoring polynomials. And I have a summary listed for us. We can use GCF to take out a term that's in every piece of what we're factoring. We have a general trinomial. And I think a lot of you probably used big X to be able to factor that. We have difference of two squares, and then we have perfect squared trinomials. So we're going to look at each of those. And for some of these, we're going to be actually solving them, because that's the whole idea of this, is that we are going to be able to factor, but that the factoring will help us solve. So in example 2 on A, we're going to go ahead and factor this. And if you look, we have a GCF we can take out, because 16 and 8 have an 8 in common. And then we can also go ahead and take out an x, because they both have one x. So then we're going to be left with 2x plus 1. And since this asks us to solve this using factoring, we'll now take our factors, which is 8x and 2x plus 1, and set those equal to 0 and solve for x in both cases. So on the first one, I'll get x is equal to 0. And then on the second one, I'm going to end up getting x is equal to -1/2. And those are my final answers. So then if we take a look at the next one, again, we're going to see if we have a GCF here. And in this case, we do. We have a 3 that we can take out of everything. So if I go ahead and take that 3 out, I'm going to be left with 2x cubed plus 4x squared minus x minus 2. And from here, I want to see, can I do anything else to this? So I'm going to go ahead and try grouping. So I'm going to go ahead and just take my 3 down here for now. And I'm going to want to group my first two pieces together and my second two pieces together. So from the first piece, I can take out a 2 and an x squared, and I'm just going to be left with x plus 2. And for my second piece, I can only take out a negative 1. But here I'll also have x plus 2. So my new factors are going to be 2x squared minus 1 and x plus 2. And see that I kept the 3 with it because that still is part of what's been factored. So now I can set each of my factors equal to 0 and solve for x. Now it's not necessary to set the 3 equal to 0 because we know that 3 doesn't equal 0. So we'll go ahead and set the other two factors equal to 0. So we have 2x squared minus 1 equals 0, and x plus 2 is equal to 0. So if I go ahead and solve for x, I'll have 2x squared equals 1. Divide both sides by 2. So I have x squared equals 1/2. And when I take the square root, I'm just going to end up with x equals plus or minus the square root of 1/2. And then in the second equation, I'm just going to end up with x equals negative 2. And those will be my final answer. Taking a look at example 3, we're going to be using either perfect squares or the difference of squares to solve these. So if we look at example A, we notice right away that we can take the square root of this 64, and if we do, it's going to work out very nicely with that 16. So most of you have learned to solve these by using big X, which is it where we have A times C on top, which in this case would be a 1 and a 64. So 1 times 64 is just 64. And then on the bottom we have B, which is 16. So then our two side numbers need to multiply to 64 and add to 16, which in this case is 8 and 8. Because this polynomial starts with a 1x squared, there's no number in front of the x squared, we can go ahead and just write our factors directly. X plus 8 and x plus 8. Now, if this x squared had a number in front of it other than 1, we would have to do a longer process using the grouping method. But now that we have x plus 8 and x plus 8, we can set both of those equal to 0 because we are actually solving. And if I solve them, I'm going to end up with x equals negative 8 and x equals negative 8. So our final answer is just x equals negative 8. In example B, the first thing that we are going to do is take out a GCF. So I'm going to pull out a 4 because that's what the 36 and the 64 have in common. And I can also go ahead and pull out an a squared. So then I'm going to be left with 9 minus 16a squared. And then I want to see, can I break that down anymore? And this is where we're looking at our perfect squares. We know that we can break 9 down because it's a perfect square, so we can break it down into 3 and 3. And then we can also break the 16 down. And based off of our difference of squares rule, we're going to have a plus and a minus. And that's because we have minus here. This is difference of squares we're talking about. And then the square root of 16 is just 4. So we're going to have a 4. And then we're also going to have that a. So 4a times 4a will give us the 16a squared. So now I can go ahead and solve these. I can set each of them equal to 0 and solve. So I have 4a squared equals 0, 3 plus 4a equals 0, and 3 minus 4a equals 0. And now I can just go ahead and solve. So I'll divide by 4. A squared is 0. Take the square root. A equals 0. We'll subtract the 3 from both sides. So I have 4a equals negative 3. Divide by the 4. So a is equal to negative 3/4. And then subtract the 3 from both sides, so I have negative 4a equals -3, divide by -4. So we end up with a is equal to positive 3/4. And those are my final answers. A equals 0, A equals -3/4, and A equals positive 3/4. And in example 4, this is just reviewing how to use the big X if that's the method that you're familiar with. And we're going to look at these two quadratics and see how we can factor those and solve. So here we'll go ahead and set up our big X. Remember, A times C goes on top, so 20 times 1 is 20. And B is going to go on the bottom, which is just 9. So we need two numbers. They need to multiply to 20 and add to 9. And if we think about it, we know that 5 times 4 is equal to 20, and 5 plus 4 is equal to 9. Remember, since this starts with just a regular x squared, we can just go ahead and write our factors. X plus 5 and x plus 4. Now to solve, we'll set each of those equal to 0 and solve for x. So I'm going to end up with x equals -5, and I'll end up with x equals -4 as my final answers. Moving on to B, we're going to do the same type of thing. We'll set up our big X. We'll have A times C on top, which in this case, we have 20 times 6, which is going to give us 120. And remember, B goes on the bottom, which is -23. So now we need two numbers for our sides that multiply to 120 and add to -23. And this may take some trial and error, you trying some different things on your calculator before you find the two numbers. But eventually you'll end up getting -15 times -8 equals 120, and -15 plus -8 equals -23. Now, as I said before, it's very important that we know what number's in front of the squared. In this case, it's a 6, so we can't just jump straight to our factors. Instead, we're going to keep our first term, which is 6y squared, and we'll keep our last term, which is plus 20. And then our middle piece is going to be those two pieces we came up with, -15 and -8. So we're going to have -15y, you must keep the y with it, and -8y. So now we can go ahead and use our grouping method, which we have used on a different problem earlier. We used, I think, on example 2. So we're going to group our first two terms and our second two terms together. From our first set of terms, we have 6y squared and -15y. We can go ahead and take out a GCF of 3y, and we're going to be left with 2y minus 5. In our second set, we can go ahead and take out a -4, so we're left with 2y minus 5. And then we can go ahead and write our new factors. We have 3y minus 4 is one factor, and 2y minus 5 is the second factor. So one factor comes from those two outside pieces. They come together to make one, and then the other factor just comes from the factor that they have in common. Now keep in mind that this common factor must be the exact same in order for this to work out. If it isn't the exact same, you've probably done something wrong. So now we can go ahead and solve this by setting our factors equal to 0. So we have 3y minus 4 is equal to 0, and 2y minus 5 equals 0. So I'm going to solve for y in both cases. And in the first case, I'm going to end up with y is equal to 4 over 3. And in the second case, I'm going to end up with y equals 5 over 2. And those are my final answers. Y equals 4/3 and y equals 5 over 2.